Hi, I'm James Sturdivant. I'm a senior software development engineer with our commercial software engineering team. I'm really excited to be here today to talk to you about transforming your business-critical .NET applications with containers and Microsoft Azure Service Fabric. Today, we're going to talk about the Service Fabric platform and see how we can actually containerize and move our existing applications, in this case, a web forms application, to the Service Fabric platform. We'll take a look at the different capabilities that Service Fabric platform brings to us, and such as scaling, rolling deployments, and then we're going to take a look at monitoring. So in this distributed world, monitoring is going to become incredibly important for us to determine what is happening inside our application. So we'll take a look at the different options we have there. And then we'll take a look at how we can take advantage of Azure's global scale to introduce fault tolerance to our application. After that, we'll take a look at how we'll actually introduce new functionality to our existing application using Service Fabric's platform and the programming models that it brings to us. So we're going to start with an introduction to Service Fabric and a place where many of us have already been. So we have a VM and an existing service. It's running and things are great. Here, things are so good that we're actually, our customers are demanding that we grow and scale our application. So we take our application, we scale it out, we add another VM, we put a load balancer in front of that, and then we add a few more VMs. Our application's now up and running, and things are great. So great that they ask us to have, our customers ask us to have another application. So we take that application, and we look at our existing infrastructure and we say, as good engineers, we want to say, let's reuse some of the stuff we have. So we run our service out there. Next, our business is growing so much that we want to we need some new internal applications to work with. And so we take those applications and we look and we run them out on some of these VMs that we have. And then we're enjoying this so much that we need to do so much more data processing that we have to run a few other services out there, and we run them out on our application, on our existing VMs. Now, if this starts to sound overwhelming to you, then you're not alone, right? And we haven't even talked about what happens if a machine dies. So if a machine dies here, what happens to those services? Do we know that they died? How do we reschedule them? So this is where Service Fabric really comes into play as a platform. In the Service Fabric world, we take our VMs, we install Service Fabric on each one of those, and then Service Fabric is able to communicate amongst the different machines in our cluster and know all the different parameters and the CPU and memory and what is available on those machines. And then that comprises of our Service Fabric cluster. We then take our services and talk directly to the Service Fabric APIs, and Service Fabric determines the best place to run the services. And in the case of a machine failure, Service Fabric will look at the existing machines in the cluster and then reschedule that workload out onto a machine that works the best for it. So Azure Service Fabric at its core is an orchestrator, but it brings so much more to the table. It brings life cycle management, it brings health monitoring, it even brings programming models on top of that. And the best part about this is that it runs on any OS in any cloud. And so if you're running it on your dev box, doing some dev test, that same bits are going to run up in Azure. It's going to run on your on-prem data center, and then it's also going to run on other clouds. So I know what you're thinking. We've been talking a lot about orchestrators and scheduling different services, but I have an existing .NET application that's been around for many years. It's stable, and that may be a fairly loose way to use that term, and it's critical to my business. How do I move that application onto the Service Fabric platform and take advantage of these things we just talked about? Well, first step is we're going to containerize our application. So we're going to take our traditional application, we're going to put it into a reusable format. We can package it up in a container. In this case, we're going to use Windows containers. Or we can take it and use a guest executable, which is just essentially a folder that has all your dependencies, and you give it to Service Fabric and it runs it across the platform. The next step is to modernize it by adding new services around it, supporting services that are going to enable you to become more agile. Up next, you can actually begin to decompose that solution that you have, that existing application that you're working with. And finally, you might get to the point where you feel like you have an entirely transformed application. Now, it's really important to realize that these are different phases, and you can stop at any of these phases, and you'll gain a lot of benefits, as you'll see today. And you don't have to necessarily go in this order. In the example that we're going to go at the end, you'll actually see how we jump over the modernize part and just, go to the decompose and extract out a service itself. So what are the steps to traditionalize an actual application? You're going to take your application, you're going to put it in a container. This is where we use Docker files. Docker files is just a description of the different services that you want to run inside your particular container. You're going to do a Docker build, which creates the Docker image. You're going to push that to the Azure Container Registry. And then you're going to tell Service Fabric to pull down those that particular version of your container that you're running. Now, you can think of the Azure Container Registry as a repository of all the different versions of your application. Now, any application out there is always going to have some sort of data source. So Azure SQL Server is the data source we're looking at today, and it's very common in some of the older applications. And what we can do is actually use Azure SQL Migration Service to migrate that up to Azure SQL Database. And so this is a pretty good story of moving our application to the Service Fabric platform. So that's enough of the talk here. We're actually going to dive in and see a demo of how we can containerize it and move it to the Service Fabric platform and some of the examples that we have, some of the examples of the power that Service Fabric brings to us. So I'm going to switch over here to our web forms application. I actually went out to the ASP.NET website and found one of the old sample applications from, I think it was 2012. I pulled the application down. It was built in Visual Studio 2012. I upgraded the application and got it to run in Visual Studio 2017. And here, it's just a simple web forms application. There's actually quite a bit going on. There's many different pages. You'll notice the ASPX. And this application runs locally. And the first step we're going to do is we're going to add Docker container support to it. So I can right-click on the project, go down to Add, and add Docker support. This takes a few seconds to just scaffold out a few things. And you'll notice immediately that there's a Docker file that is added to the solution. If we look at the Docker file, it's using Microsoft's ASP.NET 4.7. It's an image that Microsoft gives us with IIS installed and all the .NET framework and everything. It sets up a working directory in the inet pub, www.root. This is a place where you usually upload your applications in IIS. And then finally, it's just going to copy the source of this application into our Docker container. The other thing it added was a Docker Compose project. It's got a couple Docker Compose files that Visual Studio is going to use to run and build your application. Now, this is all just using standard Docker components. So you can take this Docker Compose file and run it yourself. I can press F5 or play, and it's going to boot the application. It's going to run through and build it and then deploy it. Now, while that's deploying, it takes a half a second to connect the debugger the first time. We're going to take a look at what happens in our Docker container with our Docker machine behind the scenes. So here we can see that it built out a wingtips image with dev. And if we actually go and look at the running services in the background, we'll see that the Docker Compose spun up a web service. So we actually have a web server running in the background, and the debugger has been connected to it. So here's our web application that we're going to be working with today. It's a simple e-commerce website. And here we have cars. We can maybe add a convertible car. That sounds pretty good. Rockets sound really cool to me, so I'm going to add a rocket. And I can update the quantities. I'm going to buy 2 of these cars because they're pretty cheap, and then maybe remove one of these rockets. Now, this is running inside a Windows container. You can tell because Windows containers gets a unique IP for each container that spins up on your local Windows 10 machine. And it's actually running through Visual Studio Cloud. So I've already pushed that so that it's ready to go. I'm going to snag this name here because we'll need it in a moment. So we have our container. We've containerized our existing application. I really didn't change much inside that application other than the web connection string to the SQL Server database. And then we pushed it up to the Azure Container Registry. And now we're going to add our Service Fabric project. We can go to Add. Oh, I got to start the solution here. Add New Project, Service Fabric Application. We'll call it Wingtip Toys. And I always like to put application on the end so I know that this project is essentially the Service Fabric application. And then we get to choose a solution template that we want to use for building out our application. There's a whole bunch of different options here. We'll see another one a little bit later around stateful services. But right now we're going to use the container template. I'm going to paste in the name of the Azure Container Registry and then the name of the actual image that we're going to use. Wingtip Toys version 1.0. And we'll give this a name down here. Wingtip Toys Service. And hit OK. Now, Visual Studio is going to scaffold out the Service Fabric application for us. And let's take a look at what it actually scaffolded out for us. It's got a few different files up here. I'm going to close these down so that we can look at them as we go. So over here, the first thing we'll see that it created, is our Wingtip Toys application. There's an application package root. We're going to come back to that in a moment. We'll take a look at what it actually means to describe your Service Fabric application. But in our application parameters, this is where we can do configuration for our different environments. Under our cloud here, we have the instance counts of -1. This would actually deploy it across all our machines. For our demonstration purposes, we're going to set it to 1, and then we'll scale it once it's running. Let's go back into our application manifest. Our application manifest here, we can see that it has the type that we defined before. And then the next interesting part here is the service manifest import. The service manifest import is pointing to another configuration file that says this is the configuration for the service that we're going to work with. So let's go take a look at that here. Up here, this is the Wingtip Toys service. And we'll notice down in the code package that we have an entry point and a container host. This container host is pointing at that Docker image up in Azure Container Registry here. If we scroll down, there's endpoints defined. And this is where we tell Service Fabric what's the port that we want to open up on the local machine, on the host machine for this particular service. So we're going to tell it to open up port 80, and then we're going to tell it to open up the protocol of HTTP. And now we have configured our service and we're ready to go. We have a couple more settings that we need to set up in the application manifest. In the application manifest, we'll see underneath that service manifest import, we need to tell Service Fabric what is the container image, the container host that we're going to have. So if I come down here, this is a little bit of code, so I've just saved it off to the side here. I'm going to paste it in here and then we'll talk about it. So this is our container host policies. We're saying this is the port that the container is running on, And then this is the endpoint reference here, Wingtip Toy Service Endpoint. It's really important to make sure that this is the same that is in our service endpoint here, and it is. And then this is the repository credentials to call back up to our Azure Container Registry so that it pulls it down. Now, I've hard-coded a password in here, but you can use, there are other ways to do this without hard-coding a password in there. So we are now ready to go with our application. We can take this and we'll deploy it out to Service Fabric. I have a Service Fabric cluster already out there. If I right-click and go to Publish, it's going to load a few of the different endpoints for our application. Now, here I'm doing this from Visual Studio, but in reality, in your production environment, you're going to have a build server that you're going to be working with here that you can actually deploy on source code check-in. It can run and build this stuff. So if you're using Visual Studio Team Services, there's already a template out there for Service Fabric, and you can just fill in a few parameters, and it will take this information and then go and build it and deploy it out to Service Fabric. I'm going to pick my Service Fabric cluster that I've already prepared and hit Publish. So this will take a minute or two to build the application, and let's see here, I've got an error. I think I just need to build it before I publish it. Let's try that again. So this will take a minute to build the application and then publish it out to Service Fabric. And that was the case there. I did need to actually build the application again once I got the application added to my solution. So it's building it. Let's go out to our Service Fabric cluster. And this is our Service Fabric Explorer. It kind of gives us an information around the different applications that are running. Over here, we can get information about different nodes, and then also the Service Fabric system applications that are running out there that are doing all this management for us. So now our application is running. We can come in here and click on cars. This time I'm going to add a fast car, and we can see that this is actually running up in Azure in Service Fabric. We just took our Web Forms application, added Docker support, and then running it in Azure. So one of the features that we can get now is we can take our application type, and in that service, we can scale it up. So we can scale it up to however many we want here, but we'll scale it up 3 so that we can see what that looks like. So we've submitted that information to Service Fabric. Service Fabric is already taken that information, found some machines that it can run this service on, and then started to boot them up. And in just a moment, it's already ready if we look up here on the right. And all the while, I can still continue to use my application. So what's interesting is that Service Fabric enables you to be able to handle fault tolerance. So if one of these machines goes down, we can determine, it'll automatically detect that and then reschedule that existing service. So here, this one's running on main 2. We can come over to main 2, and we can deactivate this machine. So this is just a warning that says, hey, you shouldn't do this in production because it's going to take down one of your scale set machines, and you could potentially lose data. But for our purposes, we're going to spin that down, and in just a moment, the machine will actually begin to shut down, and we'll see that that service disappeared, and it's been rescheduled on a different VM in our cluster. And again, all the while, we can still come back in here and add other carts and continue to work with our application. And we can see it's already ready here. So we're going to dive back in. That was a quick example of how we actually move in our application. One thing to note is if we go back into Visual Studio, I went through all these manual steps here. A lot of this can be scripted and it can be put onto your build server. And with the preview version of Visual Studio's Service Fabric tools, you'll be able to right-click on that existing application, and next to Add Docker Support, we'll actually say Add Docker Support for Service Fabric, and we'll scaffold all those things out so you don't have to do those extra steps that I saw. Okay, so some considerations for when you are moving an existing application. Session state, with these with web forms applications, session state was commonly used. And so you need to be aware that session state won't be shared as you scale out your application. So take that into account. There's plenty of options to either move that off or use a different approach to how you store the state that you're working with. Any memory that you're using inside your application, so if you're caching any database calls, that cache won't be replicated across your instances of your web service. So you have to probably use something like Redis as an external cache system. Or you could use one of the Service Fabric platform, Service Fabric programming models, which we'll take a look in a few minutes. And finally, now you have multiple instances all accessing the same database. Be aware that there could be some conflicts when reading and updating that data. Now, these are things that you may have already taken care of inside your application, but there's things when you're moving your application you need to be aware of. So here we are. We took our traditional application, we've containerized it, and we've run it on Service Fabric. We've already seen how we can scale it fairly easily, and then we can we can use the fault tolerance. Our next step is, now that we're running up in Service Fabric, how do we get insights into our application, how it's running, how it is performing and behaving up in the cluster? Service Fabric is agnostic to monitoring. Service Fabric actually is agnostic to monitoring, and so there's a whole bunch of different ways that you can go about monitoring, but there are 3 different levels of monitoring that I like to think about. The first one is infrastructure. Infrastructure is our nodes and our containers. It's our disk input, output, memory, CPU at a very kind of granular level. The next level that I begin to look at is the platform level. So things that are happening inside our Service Fabric cluster. Some of those is Service Fabric may determine that your clusters needs to be rebalanced so that resources can be used effectively. And so it puts out events for that. If an application fails and dies and moves to a different server, there's also events for that. And then finally is your application. And this is where you're looking for unique insights into your application. So it's going to be very specific to events that happen inside your particular service or the performance of your application. So how many milliseconds or seconds it takes to process a request. If you see that spike up, you might know that something's kind of behaving improperly. So again, Service Fabric is agnostic to the types of monitoring that we do. And there's advantages to all the different types. One option that you have is OMS, and this is great at the infrastructure and platform level. It also has a pre-configured template that's going to give you information for your CPU, memory, application, Service Fabric platform events, all of that stuff. So it organizes it in a very nice way for you. Application Insights is another information happening in the operational channel. We're getting our container log, so we can dive in to each individual container and look at a particular log that's coming back out. It's collecting our standard out and standard error. So this is very useful to just extract that information fairly quickly. We're also getting reliable service events, and we get a count of the applications that we have out there and even the images. And here you can see that there's a whole bunch of images. As I was doing debugging and testing for this presentation, I've collected some of that information there. It's also giving me container metric and node metrics. The container metrics are a little spotty because some of the containers were spinning up and shutting down, and then I wouldn't run them for a few hours, and then I would run them again. And so there's all different metrics in here for that, what's coming up, and node metrics. Now, if I come into my settings for OMS, there's a few items in here that I want to point out. You'll see that I have a couple different solutions that I can easily add. They're pre-configured dashboards, essentially. And then underneath connected sources, you'll see that I have my Windows servers and the 5 computers in my node. Under data, I can come in and add Windows performance counters. I've already added a whole bunch of those, but Service Fabric emits a ton of performance counters around everything that's happening inside the system. And so you can come in here and configure them, and they'll show up in your logs here. This is a great way to get insight into your Service Fabric cluster and how it's performing. So that's a really quick demo of OMS, but we're going to dive back in and start talking about how we can take advantage of the Azure platform and its global scale. So now that we have taken our application and pushed it up to Azure, it's running in Service Fabric. And since Service Fabric is just an orchestrator, it takes the VMs and it determines where the services should run, you can change the topology of your underlying infrastructure, and Service Fabric will just start to schedule machines out there. And one of the things that we can take advantage of is the newly released availability zones in Azure. Availability zones are physically separated locations within an Azure region. Each zone has its own independent power, network, and cooling. And so if one of these zones goes down, your application, if it's configured to run across all three, would continue to run. With Service Fabric, this is fairly simple to set up by configuring an ARM template. Now, there's 3 zones in each Azure, each availability zone enabled region. And another thing to note is that availability zone communication, the network latency can be up to 2 milliseconds. Within a availability zone, it'll be around 1 millisecond. So there is that consideration to take there, but I mean, 2 milliseconds is fairly small. Now, I'm not going to dive into the deep ARM template today. There are some solutions up on GitHub for you to take a look at that. But what we will do is look at a high level. So the way that this gets set up is that you set up in a single VNet, and then in each one of the availability zones, you run virtual machine scale sets with a load balancer in front of them. And then you use subnets to connect them all 3 together. And Service Fabric, there's one Service Fabric cluster that is able to monitor all the machines across that system. So if one of these availability zones goes down, Service Fabric will recognize that and start to move the services to the other 2 availability zones. Now, there's a traffic manager, and that's actually optional in availability zones because you can actually have a virtual IP address across all 3 availability zones. But many times, if you're going to be going to this AZ world, you're going to probably end up going to cross-regional clusters as well. And so having the traffic manager out in front of there will prepare you and get you ready for that scenario. So a cross-regional Service Fabric cluster is also something that you could set up. So you can set it up to run across 3 different regions. And this is really where you want to survive an entire Azure region going down. And this is where you're looking at your RPO and RTO, which are essentially how much data loss and how much time after the disaster happens that you have recovery. You want that to be 0. And so if an Azure data region goes down, you don't have to necessarily spin up services in another location. Service Fabric is going to manage that for you, recognize it, and everything will still continue to run. Now, there's a few minimum things that you need to have. The first one is 3. You have to use at least 3 regions, and then you have to have at least 9 VMs minimum. And so this can get fairly pricey fairly quickly, so just keep that in mind. But if you're really looking for that high fault tolerance, this is a solution that you need to move to. And there's 36 Azure regions across the globe, so you can really begin to leverage the global scale of Azure. And it's important to note here that you don't have to actually take your Service Fabric application and change it in any way. You just are able to deploy it back out to this Service Fabric cluster that's been configured to run across the availability zones or the different regions. Now we're going to dive into talking about how do we actually modernize our application and begin to move to a microservices design pattern. So we've containerized our application, where we can now begin to add services around the outside and supporting services in a microservices manner, or we can begin to decompose it. And we're going to jump right into decompose. just to demonstrate that you don't necessarily need to move along this path in a modular way. You can kind of jump around. You're very flexible. You do what's best for the business that you're running. So how do you decide where you're going to actually begin to add new features? The first one is if you have a new feature coming up and it's fairly independent logic-wise and data source, this is a great opportunity for you to try out adding a new service in Service Fabric. Another place is where we can use monitoring. So again, we talked about monitoring a little bit from a global, more broad perspective, but we can put monitoring in our application to determine hot paths and existing bottlenecks where we're not able to scale. And so this is a great place where if we see a hot path or a bottleneck in our application and in our architecture, we can extract that out into a separate service. And it's important to realize that we should always start with small features. Now that your application is running up in Service Fabric on the Azure platform, there's some sort of latency. And so we need to be aware of that. Now, the benefits that we get from increased mobility and agility and independent deployability and scale usually outweigh that latency hop, but it is something to consider. Now, another thing is now that we have that network hop, there could be failures. And so we need to have some sort of failure and retry strategy. So if the service goes down, do we continually retry until it comes back up? Do we back off exponentially? What happens if there's a cascading set of failures? We need to come up with some sort of strategy for all these different scenarios, and it's going to be different from one service to another. Now, there's also existing patterns out there, such as the circuit breaker pattern, and that circuit breaker pattern will enable you to handle some of these failures, cascading failures and such. Now, we touched upon shared state previously, but when we start to break out services, we're going to have some information shared between our different data sources. And so we need to be aware of that shared state and how it's being shared, and determine whether or not some of that data can be stale, how long it can be stale. There's a whole bunch of different things that we need to think about here. And so these are just a few different ideas to keep in mind as you begin to your migration to a Service Fabric and microservices solution. So Service Fabric brings these stateful programming models on top of just being an orchestrator. The first one that it brings is this stateful reliable services. This essentially enables you to work with your state through a key value pair dictionary with transactions support built in. So an existing application, generally you have some sort of stateless front end. That's kind of your jQuery and Angular and all of those other applications out there. And that's calling out to a middle tier where there's compute, and then that calls out to a database. In the Service Fabric world, you call out to a stateful middle tier. So we've taken the data and brought it up next to the compute. And this enables lower latency, less management with how those calls need to be made out to the database. So this is an incredibly powerful technique, and it also enables us to start to begin to think about how we actually partition our solution and run our solution in a distributed manner. On top of that, there's also the actor model. And the actor model is a great programming model for when your particular solution really fits in the way that you scale. But you got to make sure that it's fitting into the actor model really well. So we are going to go into that existing web forms application that we have already seen, and then we are going to extract out the shopping cart. So we're going to go in and extract out existing solutions. The reason we chose the shopping cart in this scenario is because it's a small feature. It's a fairly existing module within the solution, but it's also incredibly important to scale. And important to the business. This is where all the revenue really comes through. It also opens up new interactions. If we extract this out into a service, we're able to scale it and enable our mobile applications and our email marketing campaigns to interact with our shopping cart to extract new information and hopefully serve our customers better. And then low latency is incredibly important in this scenario. I mentioned that the revenue, this is the key source of revenue for the organization, and so we want that shopping cart to load quickly. We don't want them to have to wait because they might go to another store. And so using the reliable services will get that low latency kind of out of the box using the stateful middle tier. So we're going to dive in and take a look at what one of these demos looks like. So in the, I've already pushed the code out, and we're going to take a look at all that code. There was quite a bit of code that had to be written to extract out the service, so we weren't going to be able to do that live. So the first thing you'll notice is that I have a new project here called our shopping cart. And if we go into our Wingtips Toys application, and we look at our application manifest, we'll see that I now have a service manifest, and I'm bringing in this shopping cart package. The first thing we're going to do is kick this off and upgrade the existing solution that we have out there, and then I'll walk you through some of the code that we've changed. So I can right-click on my Wingtips application, click Publish, and this time I'm going to check this checkbox for Upgrade the application. I'm going to push it out to the same solution, and then click Publish. And this is going to build the application and then initiate an upgrade. And so now we'll be able to see the rolling upgrade happen in time. I'm kicking this off while we go back and look at the code because it can take a few moments to complete the entire upgrade across our 5 different upgrade domains. So here it is building the application. And in a moment, it should kick off the upgrade. We'll make sure it's successful, and then we'll go take a look at what it looks like inside our Service Fabric Explorer here in a moment. Let's see. The Wingtip service upgrade in progress. But we can take a look at our cluster map. So we have our machines running across multiple fault domains and multiple upgrade domains. So that means we're going to be able to do this rolling upgrade across our service while it stays up. So it'll take down the first machine, but the other machines will stay up as it's upgrading the service. Wingtip Toys service package, but the version number is the same. I thought I upgraded that. Let's check one more time. We'll try one more time here. And kick it off, and then we'll go look at the code. So I'm going to kick that off. While that's kicking off, hopefully we'll be successful this time. And we'll go look at the code that we've modified. So inside our shopping cart, so here we've added a service. I've already added it, but the way we would add this is right-click, add new Service Fabric solution service, and it would template out and give us those options that we saw previously, and add it to our application manifest. And then in here, in our shopping cart, this is an ASP.NET Core reliable stateful service. And if we go to our program, this is where we would typically see our ASP.NET Core startup information here. Instead, we're seeing where we're actually registering it with Service Fabric. We're registering the shopping cart class. If we go take a look at what that shopping cart class looks like, we'll see that shopping cart inherits from stateful service. And below, we'll see that we have create service replica listeners. And this is where we're actually configuring our Service Fabric, our ASP.NET Core application. So here, you can even see that we are configuring up our dependency injection for ASP.NET Core. If we go out to, and we're also setting our startup class. If we go to startup class, this is just going to be ASP.NET Core. So we have our startup, we have our configuration services, and we have our configure. You can see I've added Swagger in here and a few other things. And if we go up to our cart controller, we'll see again, this is just an ASP.NET Core controller. But on our constructor, we've actually injected in the reliable state manager. That state manager is where we're actually going to interact with the different replicas that we have for managing our state. I've mentioned that that the state is just a reliable dictionary. So in this line here, we're just telling the state manager, hey, go get the dictionary for us. And this dictionary is going to have a key of string and a value of cart. We create a transaction. Anytime we're working with these reliable dictionaries, we're always going to work with transactions. This way, if something fails during one of those transactions, it'll automatically get rolled back for us. We're going to try and get the value out of the dictionary and put it in a result. If the result has a value, we'll return the items. If not, it's going to just return an empty list. So this is deceptively simple for what is actually happening in the background. In the background, your data is being replicated reliably across many nodes. And if one of these nodes goes down, then your data will still be around and it will automatically figure out how to do leader elections so that your service pops up and stays alive for you. But you can see how simple the programming model is when you're working with it. Let's look at a little bit more complicated one that uses some transactions. So down here, this is our Wingtips WPF application, web forms application. And in here, if we go into our logic, we'll see that it was already separated out into the shopping cart actions. This shopping cart actions was kind of where all the business logic relied to access the data. I've extracted out, it was using Entity Framework to pull that information out of the database. And instead of calling to Entity Framework, what I've done here is call out to a web service. I'm using refit to make it fairly simple to call out to those web services. And I return a client, and then I call add item. If I go and look at this interface here, refit enables me to just define my web client through this interface. I can specify the endpoints that we're working with in these attributes, and you'll notice that they kind of match to all the different ones that we had in our ASP.NET Core reliable service. If I go back to shopping carts, when I actually call to add an item to it, you'll notice I'm also passing off a partition key. I mentioned that these reliable services are partition aware. Now, in this solution, I'm exposing the client to the partition key here because I wanted to kind of show that here. But we can also hide this partition information in another service. So we can have a kind of a stateless solution in the middle where if you call out to it and you supply the shopping cart ID, it will automatically figure out how to connect to the right partition in your application. If we scroll down to a little bit further, down to let's get the cart items. Now, this existing application was working with the database. And so the product information and the cart information was all in the same database. We've extracted that out and put it into a separate data store, the reliable collections. And so when we get that information back from our web service, we need to merge it with the product information. And so I've written a little class that takes that and calls down to SQL Server and then merges those back together and returns it back to the client to display it. So there's a little bit of merging of data that you need to do here. It's not too bad. If we take a look at that functionality here, I'm using link to just join a couple of the things together on the product IDs after I call out to the database. So you also notice that I'm using async await. So that required a little bit of change to my solution. So if I go into my web forms application, let's see here, shopping cart. If I go into my web forms application, on the page load, I needed to enable async support in web forms. And so in web forms, you go into your ASPX page and you enable async true. And then inside your page load, you use register async task. Now, I wanted to modernize my application. I didn't want to just continue doing the same things that I've been doing in the past. And so that's why I introduced this async await. Required quite a few changes across my solution, but ultimately, I think it makes a better solution here. I've even upgraded and started using the latest version of C#, so C# 7.1. That required just a small change to bring in some libraries, some NuGet packages to enable the compiler when the thing boots up. So with any luck, we should see that our application has gone out and did a rolling upgrade. So if we come out to well, it didn't get the rolling upgrade because I think I got some naming things wrong. But it did go out and deploy a new service. Let's see. Is this this new service? But it does work. It added new functionality using Service Fabric reliable collections and extracted a component of our application and turned it into a microservices, started our journey towards microservices. So the source code for the solution with all the commits to make all the different changes is out on my GitHub here, github.com/jsturtevant Service Fabric Modernize Connect 2017. So you can go take a look at that. You can download it. You can build it. There's some scripts to set up the infrastructure and get yourself set up. Next, there's a lot of information out there for you to learn more about Service Fabric. So you can go over to docs.microsoft.com and check out the Service Fabric documentation. There are a ton of free open source samples out there. There's even free clusters for you to try. And then there's an incredibly comprehensive resource list that's been put together by one of the community members. There's also documentation on more information around how you actually migrate to the cloud. And then if you have any questions, comments, concerns, go out to the Service Fabric forum and the Service Fabric issues and raise an issue and ask us questions. The team is out there and they're happy to answer questions. So with that, my name is James Sturtevant. I'm a senior development engineer on our commercial software engineering team, and I'm so excited to share this information with you and for you to take it and run with it. And I wish you luck on your journey to Azure and microservices.